In this lesson in the text, we're looking at kites and trapezoids. In this video, in order to make sure that I'm sticking to my 25 minutes or less rule, in this video I'm only going to talk about kites. So a kite is a quadrilateral with two pairs of consecutive congruent sides, distinct pairs of consecutive congruent sides. So you'll notice that PQ is congruent to PS, that QR is congruent to SR, but that PQ, for example, is not congruent to QR. So it's asking us to measure the angles and sides, measure the angles made by the sides and diagonals of a kite, noticing any relationships. All right, so if I take this kite and I measure the angle formed by the diagonals, it's 90 degrees. Okay, so my diagonals are perpendicular. If I measure angle TPQ, that is about, I don't know, maybe 22. And if I measure angle TPS, it is also just about 22. So this diagonal bisected this angle of the kite. Does it also bisect the other angle? Okay, so that angle is about 40, let's say 45. This angle QRT, that's also just about 45. Okay, so a couple of observations we've made. What do our results tell you about the kite's diagonals, PR and QS? Diagonals, oops. Put this back where I had it. Diagonals of a kite are perpendicular. And use a protractor to measure angle PQR and PSR. I didn't measure that, but I did measure angle QPS. Oh no, I didn't measure QPS and QRS, but I did measure QPT and SPT. And when I add them together, they are not going to equal what QRT and SRT added up to would equal. So I know that they are not congruent. And let's measure the angles that they suggested that we measure. So angle PSR and PQR. Okay, so PSR is approximately, let's say 115. And QPR is also just about 115. So they are congruent. Okay, so we want to make sure that we can distinguish between, in a kite, which angles are going to be congruent and which ones are not. So what I'd like you to notice is that the angles that are congruent are the angles formed by the non-congruent sides, whereas the angles that are not congruent are formed by the congruent sides. So let's see how they address that. Well, first they have us constructing a kite. So I've got a blank screen. Let's do that. Okay, so first thing it says is to make a compass setting of my choosing, but I want to start with a dot. Okay, so I'm going to make a point here, and I'm going to call this point A. Okay, so here's my point A. And from A, using my random compass setting, I'm going to create two other points. Whoops, that did not do what I wanted it to do. This is what I wanted to move. All right, so if I pick any 2 points on this arc, they will be equidistant from point A. So let's say this and this. So now I'm going to call those points, well, what did they say to call them? Oh, I'm all kinds of labeling wrong. So this is B and this is A. And this point here is C. So now I'm going to change my compass setting, and from A, I'm going to make an arc. And from C, I'm going to make the same arc. And that intersection of arcs, that's my point D. And when I connect these dots, A, B, C, D is a kite. And it says to measure the angles of the kite that I've constructed. I'm not going to do that. The results would be the same. So in the kite that I constructed in steps D through F, they want us to look at angles CDE and ADE. Okay, so CDE and ADE. I imagine E is the intersection of my diagonals. So CDE and ADE. What do I notice? They're congruent. Is this also true for CBE and ABE? Yes, they are also congruent. And then how can I state this in terms of the diagonal AC and the pair of congruent, non-congruent angles? Okay, so they are congruent. So the diagonal that connects the non-congruent opposite angles bisects those angles. In the kite that we constructed, look at EC and EA. What do we notice? EC and EA. Now that's something that we didn't measure in the other kites. So let me pull out my ruler, because this is a measurement that we haven't already talked about. So if I measure AE, that's about 1.5 centimeters, and then I measure EC, that's also about 1.5 centimeters. So Is this also true for EB and ED? Well, very obviously, visually, we see that EB is not congruent to ED. So no, that's not also true there. So which diagonal is a perpendicular bisector? Because we've already established back here that the diagonals of a kite are perpendicular. But even more so, we can say that the diagonal between the non-congruent angles is the perpendicular bisector of the other diagonal. So the diagonal that connects the non-congruent opposite angles is the perpendicular bisector of the diagonal connecting the congruent angles. So now they're taking the observations that we've already made and stating them as theorems. Thanks for telling me something I already knew. So if a quadrilateral is a kite, then its diagonals are perpendicular. We've already established that. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So you'll notice that that's angle PQR and PSR in this diagram. If a quadrilateral is a kite, then one of the diagonals bisects the pair of the non-congruent If a quadrilateral is a kite, then one of the diagonals bisects the pair of non-congruent angles, and if a quadrilateral is a kite, then exactly one diagonal bisects the other. So actually, the statements that I made on the previous screen, I hope you'll notice, are a little bit more precise than the theorems that they're giving you. So hopefully they help you in using properties of kites to find unknown measures. So in example 1, they're kind of talking you through the whole thing. They're asking for the measure of angle CBE. In the instructions, they gave that angle BAE, that's this angle here, is 32. And they gave that angle BCE is 62. So in part A, they're asking for angle CBE, and we know that the diagonals of a kite are perpendicular, so we know that the measure of angle BEC is 90 degrees, so it's a triangle. And they're talking about how it's a right triangle. This is a valuable observation to make, that in a right triangle, the acute angles will be complementary, so BCE, which I know is 62, plus CBE has to add up to 90. So when you solve that equation, you find that CBE is 28. In part B, we're asked for angle ABE. Well, ABE is also a right triangle. Therefore, its acute angles will also be complementary. So angle ABE plus the measure of angle EAB will equal 90. And if I substitute 32 degrees in for EAB, and then I'm going to solve for ABE. So ABE plus 32 equals 90, and when I subtract that 32 from both sides, I get 58 degrees. For part A and part B, what strategy could we use to determine the measure of angle ADC? Okay, we could use the fact that the angles of this triangle have to add up to 180. So we could add 62 plus 32 to get 94. Subtract that from 180 to find angle ABC, and that would be 86. And since angle ABC is congruent to angle ADC, angle ADC would also be 86. Okay, so we could use triangle angle sum theorem in triangle ABC to find that the measure of angle ABC equals, I can't remember what I said, 180 minus 94 is 86. So measure of angle ADC will also equal 86. Oh, hey, look at that. They're asking us for the measure of angle ADC. Isn't that your turn? We already did that.